This is AIME 2014 to number 14. So we have a geometry problem. So let's start drawing it out. We have triangle ABC and we're given AB is 10 and 2 of the angles, so we can solve for the third one. So I'm gonna draw ABC. And angle A, we know it's 30 degrees. And then angle C is 45. And then we know AB is 10. And now we're going to add points H, D, and M on line BC. So let me extend BC such that AH is perpendicular to BC. So it looks like H is just the foot of the altitude. And then angle BAD equals angle CAD. So D is going to be the the angle bisector of this triangle. Okay, so then this means this gets split into 15 and 15 degrees. Okay, and then BM equals CM. So M is just the midpoint of side BC. Okay, now N is the midpoint of HM. So let's say it's around here. And then P is on ray AD such that PN perpendicular to BC. So BC is here, so it's going to be an altitude, sort of like that. Okay, then we're looking for the square of the length of AP. So something nice about this problem is the very nice angles. We're given 30 degrees, 45 degrees, 15 degrees. That suggests we're going to be working with some kind of trig. So, well, immediately, if we look at this big triangle, it's actually a 45, 45, 90 triangle, right? 45, 90, that has to be 45, meaning that this angle is 15 degrees. So that's pretty useful because we know AB is 10. Now we can find AH. So AH is just 10 cosine of 15. And similar for here, HB is just 10 sine 15. And this altitude is really nice because we can start computing lengths pretty quickly. Because say we wanted HD, okay, well that's just, we know we have this triangle with angle 30 and we know the height, so we can use trig to find it. And same for other lengths like HC. So it might be a little bit messy trying to label everything on a diagram, so let's just stick to what we want to find. So we want to find AP, and that's not very easy to find because P is kind of defined based on N. It's not, doesn't really fit with this height. So instead, I'm thinking we use similar triangles. So we note that triangle HAD is similar to triangle NPD. So we can set up some side ratios involving AP, and that will definitely help us solve for the value of AP if we can calculate the rest of the values. So let's go ahead and do that. We can write something like AP over AD equals HN over HD. Okay, so if we find the other three values, we can easily find AP. So let's start doing that. Okay, first we can try to find AD. And that shouldn't be too hard because we know this angle is 30, we know this height, so we can write cosine of 30 is adjacent over hypotenuse. Okay, so then solving, we get that AD is 10 cosine 15 over cosine 30. And I'm not evaluating these right away, just in case some trig values, simplify. So that's AD. Next, we'll go for HD. And I skipped over HN. That'll be a little more tricky. Let's just do HD. We use the same triangle. This time, we're going to do tan 30. And that's going to be opposite over adjacent. Okay, so then solving for HD. HD is equal to 10 cosine 15 tan 30. Okay, awesome. Now the last side we need to find is HN. And that's a little more tricky because it's involving n. Looking at that length, it's not immediately obvious how we're going to find it, but we haven't used some definitions yet. N is the midpoint of HM, so we haven't even used that information. So what we can do is write HN is a half the length of HM. Okay, well, can we find HM? Again, it's not very obvious, but we can write HM as the difference of HC and then subtract MC. And this is better because we can find HC, right? We have this 45-degree angle, we have 10 cos 15. In fact, HC is 10 cosine 15, right? Because our whole triangle is 45, 45, 90, even if it doesn't look like it. So now how do we find MC? Well, it's not very obvious, but M is the midpoint of BC. So actually MC is half the length of BC. And BC shouldn't be hard to find because BC plus HB, which we know, gives HC, which we know. So that might be a bit confusing. Let's keep writing it out. 1/2 HC, and remember MC is just a half BC, right? Because M is the midpoint. And finally we rewrite BC as basically HC minus HB. And now we can compute all these values. So first I'll simplify a bit. We have half HC minus a quarter HC plus a quarter HB. So we're left with a quarter HC plus HB. And now we can actually find these values. So as I mentioned before, HC, well, just the same as HA. So 10 cosine of 15. And then HB, we already found, is 10 sine 15. Okay. So we found HN. 5/2 cos 15 plus sine 15. All right, we're ready to plug in to our side ratios, and now we can solve. So I'm just gonna bring this down here, AP, and I'm gonna move AD to the other side. So HN over HD times AD. Now we can plug in these values. hn we know to be 5 halves cosine 15 plus sine 15. hd, we know that, 10 cosine 15 tan 30. And then finally AD, 10 cosine 15 over cosine 30. All right, so we can cancel 10 cos 15 with 10 cos 15. Remember that tan 30 is just sine over cos, so we can simplify like that. And sine 30 is 1/2, so we can cancel the halves like that. And we're left with 5 cosine 15 plus sine 15. And here, if you know the values off the top of your head, you can plug them in and square AP. But if you don't know the values of sine and cosine 15, that's okay, because the problem is asking for AP squared. So if we square this, we're going to get cosine squared 15 plus sine squared 15 plus 2 cosine 15 sine 15. And from our trig identities, we know sine squared plus cosine squared is just 1. And we also know that this looks a lot like sine 2 theta. And in fact it is. 2 cosine theta sine theta is equal to just sine 2 theta. So that's just sine 30, which is 1/2. So 25 times 3/2, 75 halves. We're looking for m plus n, so that's just 75 plus 2, which is 77, and we're done.